Okay, silly people, here's the situation. Uh, what we're doing right now is we need to find the eigenvalues and eigenvectors of the poly Y matrix. Um, and then calculate the um, probability that a um, a particle in a state given by the column vector alpha beta when measured by Sy is going to be equal to h bar over 2. Um, and the problem is stated in vector matrix notation, so I'm just going to do the whole problem in that notation. Starting with the eigenvalues, which will be given by this equation here. I'm going to have lambda be my symbol for eigenvalues, um, because of course I am. The determinant of that matrix is equal to 0, which is going to read lambda squared minus I squared is equal to 0. Um, it's actually lambda squared is equal to lambda squared equals minus I squared, which when you square root both sides, you'll get a positive 1 and a negative 1 for your two different eigenvalues. Right. To find the eigenvectors, then set up your eigenvector equation. I'm going to have my eigenvector be called x1, y1, using the first eigenvalue, 1. It's going to be x1, y1 on the other side, which will give us minus I y1 is equal to x1, and I x1 is equal to y1. That is actually all you need um, to set up the eigenvector. Um, we're just going to have, let's see, we're going to have the first eigenvector be then 1 over root 2 to normalize it. We'll set x1 equal to 1, which means y1 will have to be positive I. Going for our second eigenvector now, we'll have 0 minus 1 I 0 x2 y2 equal to minus x2 y2, which means we'll have minus I y2 is equal to minus x2, and I x2 is equal to minus y2. Which means these minus signs will be canceled out. And now our second eigenvector will be 1 over root 2 times, I'm going to have the first one be 1 again, and then the second one will end up having to be minus I. Okay. So that's pretty awesome. You may recognize these as being equal to 1 over h bar times the up y basis vector, and 1 over h bar times the down y basis vector, because after all, I think it's, no, that's it. Because after all, the sy operator is just given by h bar over 2 times the poly y matrix, which is the assumption that we're going to make whenever we're solving for the probabilities that we're about to do. So we're solving for the probability that we measure h bar over 2 for a state that is starting as alpha beta. Physically measuring h bar over 2 translates into ending up with a state in being up along y. So calculating the probability is actually just the inner product of up y with the new state psi, taking the square modulus of that. So let's just do that. Because we had 1 over root 2, putting it into the bra form will make it be the complex conjugate. So it's going to be 1 minus I there. And this is multiplied by alpha beta, the column, square modulus of that, which will give us alpha over root 2 plus beta, no, minus I beta over root 2 under a square modulus. Doing the square modulus is actually just multiplying the complex conjugate of what's inside times itself. So you'll actually have, I'm going to factor out a 1/2 first. It'll be alpha plus I beta times alpha minus I beta, which whenever you do that, you'll end up with alpha squared minus I alpha beta plus I alpha beta plus I squared. It's actually minus I squared beta squared, which is 1 over 2 alpha squared plus beta squared. So the probability that it measures h bar over 2 is alpha squared over 2 plus beta squared over 2. How you like that?